So let's start this. All right. So off we go. And we're live, I believe. Yes, I see some participants. Well, it's good to be back. It's been a while that I wasn't hosting one of these, and so super excited. Ben, welcome. Thank you for doing this, man. Appreciate it. Yeah, I don't know, like I haven't done this in a while. The community has grown so much since I last did it. For everyone that's joining, and we'll wait a couple of minutes as people roll in, but we've launched in the last few months platformengineering.org. That was very well received. Right before that, we launched a platform engineering Slack channel, which is now about 1,600 members really engaged. So I recommend everyone just jump in there just gets into the conversation there. Also, feel free to drop your where you're joining from in the chat so that we can say hello and we can see where everyone is coming from. While we wait for everyone to join, we give people another 1 or 2 minutes. Couple of housekeeping rules, as always. This session will be recorded. Oh, there you go. People coming in. Hello. Will from Belgium. Oh, Nola. Nice. Yeah, so housekeeping rules, I was saying, the session will be recorded, so no need to go crazy on notes or anything. We'll share it later per email, probably tomorrow morning for Europe and in the night for US. In general, as a format, Ben will do a 20-30 minute session, and then we'll open it up for questions. So, feel free to drop your questions in the, it's a lot of people from the West Coast. Feel free to drop your questions in the chat or in the Q&A anytime, and then either Ben will answer them as we go if it makes sense. Otherwise, we'll keep them for the Q&A at the end. Awesome. With that said, I think we're super excited to have Ben with us today. Super impressive profile. He's the co-creator of Dapper, which is Google's distributed tracing system, at Monarch, which is another Google system, as well as OpenTelemetry, which is what we're talking about today. And he's also the founder of Lightstep. So thank you so much for doing this, Ben. I'll hand it off to you, and I'll shut up.
Thanks, Luca, and thanks everyone for joining. I'm excited about this. I wanted to talk about OpenTelemetry, and I will, although I realized that I think there's quite a bit of content out there about OpenTelemetry at kind of a very low elevation, but there's not a lot that sets the context for the overall problem space of observability and how OpenTelemetry fits in. So the talk I'll do today, I will get into some of the mechanics around OpenTelemetry, but I'm going to also step back initially and just talk about some of the larger contexts of cloud native observability and the problems that I think are pretty rampant in the space right now, and how OpenTelemetry fits into that. And then if we have time at the end before questions, I might do a quick demo just of how things can fit together into an actual solution. So without further ado.
And as you kick things off, Ben, maybe I just run the poll. Just a quick run for everyone, just to see what's your experience with OpenTelemetry. So I launched it now, so you can just answer, so that Ben has some context around what you all know about this. So our answers rolling in. You see it, right,
Yep.
Ben? Okay.
I do. I wish we could play the Jeopardy theme music right now.
A little elevator music. Yeah. Just okay, you got it, Ben. All right, I'll shut up again.
Actually, let me not share my entire screen. That's always a little dangerous. Let's see. All right. Okay, cool. Is the poll still going, Luca? I think it is, right?
Yeah, I think it's still going, but I guess we can assume this is the more or less the final distribution. So
Yeah,
it looks like a lot of beginners, few advanced, few pros, and a few that have no idea.
okay, sounds good.
Awesome.
All right,
I'll
well,
end the poll now, and
sounds
off
good.
you.
Thank you. So my talk is cloud native observability done right, with kind of a focus on OpenTelemetry and how to get started with the project. I actually wanted to begin by stepping way back to talk about what I would call resources and transactions. I've written about this a bit on Twitter and elsewhere, but I think this is a really nice way of getting kind of a conceptual framework to then think about things like OpenTelemetry and also observability in general. So the diagrams, sorry for the handwriting, it's all my fault, but you can think of for any large system, like large software engineering system, you're going to have some series of resources and a bunch of transactions flowing through those resources. So the resources vary hierarchically. Like you have resources like a microservice running in Kubernetes. A resource could also be something like a Kafka cluster. It can even be something as small as like an individual mutex lock or something like that. Resources by definition are shared, and they're also by definition finite. So there's no such thing as an infinite resource. Maybe people try to sell you those things, but it's never true. They cost money, and they usually you can get to a point where you can't have more of them even if you want it. And so resources can be exhausted. And then you have transactions. And this is, you might call it a request or, a business flow or something like that. But this is just the actual work that your customers or users are trying to do and how it flows through these resources. These are the two most fundamental aspects, I think, for understanding a workload and for observability. Now, the key thing is that the type of telemetry, because we'll be talking about OpenTelemetry, that you're going to get about transactions is basically like event-oriented telemetry. This originally in the olden days was just plain old logging. I think at some point people realized that it's easier to do observability type workloads if you have more structure to the logs. And then we realized, actually Google in the early 2000s, and I think everyone else has realized since, that what you really want to be able to do is follow transactions from one service to another. At that point, it becomes a distributed trace. But really, the type of telemetry you get from the transactions themselves is event-oriented telemetry. So I think ideally it's tracing. Sometimes it's also a lot of logging, but it's actually those two types of data are quite similar. There's only a slight difference in that you have a little extra context for a trace. And then for the resources, most of the data you have coming out of resources will be in the form of metrics of some kind. There are gauge metrics like CPU and memory, and then there are metrics that count things, request counters. I don't know, I mean, I could go on and on. I mean, you can even count things into histograms to do latency, but you're going to have metrics that look at the health of the resource. So I've tried to picture this here. For a microservice, it might be CPU and RAM. For a Kafka cluster, you might be looking at the lag that consumers and producers see. For a mutex, you might be looking at how long a given lock reader or writer needs to wait to acquire that mutex. So you have metrics telemetry streaming out of resources, and I would say tracing and logging telemetry streaming out of the transactions. And that's kind of the workload. Now, the slide where it got kind of messed up apparently, but these two things are completely codependent. By that, what I mean is if you exhaust a resource, which is to say, let's say your CPU spikes to 100% or you run out of memory, that has a profound effect on the transactions going through it. They'll start queuing and they'll either fail or be super slow or both. Similarly, if you have some sudden change in your workload, like a single customer might increase their request rate by 100x or 1000x programmatically, that can have a profound effect on resource health. And then when those resources break, that affects other transactions. You might, the canonical example of this is that you have some new query that starts happening in your SQL database. Your SQL database runs out of CPU, and then suddenly everything, not just that one query, but everything grinds to a halt. That's an example of a transaction, a change in transaction behavior causing exhaustion in a resource, causing like massive systemic failure in other transactions. I'm sure that's familiar too. Now, here's the catch. Customers or end users, they only care about transactions. Like by definition, they don't give a shit, frankly, sorry, bad language, about your resources. They just want their transactions to work, period. And then the great tragedy is that although engineers and operators and SREs, what they want to do is provide a good end user experience, the only thing we can control as engineers is resources. We can't go in and like manually satisfy transactions. That doesn't scale and it's not even feasible. So the only lever we have is resources, but the only thing end users care about is transactions. And this is why observability, I think, is so hard, is that the things that we can observe transactions to a certain extent, but we can't control them. And then we can observe resources, but and control them even, but end users don't care about them. And so being able to bridge these two things is really hard and really important. I hope that makes sense. And I would also say the end users and the developers or operators or DevOps engineers, they're totally codependent too. So this is kind of our predicament, right? I promise I'll get into OpenTelemetry, but I think this kind of framework is really helpful for thinking about like the problems we're really trying to solve and how all this data, this telemetry, it's much, I think, easier to understand the value proposition for unifying it if you can understand like at a fundamental level why these two types of data, event data and statistical data, are so closely correlated. Okay, so I'm doing okay on time. All right, so now about cloud native, the promise and the disappointment of cloud native. The idea with cloud native is pretty simple. You've got some application. It's very important to your business because it's going to be the foundation of your relationship with your customers and end users. And so in order to innovate faster, you try to throw developers at the problem, but we can't get more than 10 or 20 developers to operate efficiently for some deployable unit of software because it's too hard to coordinate around release schedules and testing and so on. So we split the application into small pieces that are represented by these gray boxes called microservices. And then each microservice gets a team of people kind of pictured by these groups over here that can both develop and operate those services. So this is kind of the DevOps and microservices and cloud native pitch all in one. And it's all about parallelization. And there is some truth to this, and this does work. I mean, I think I saw a great talk by Sarah Wells, who I don't remember her title, but she has some kind of fancy title at Financial Times in London. And she's done some great talks talking about their move from a monolithic architecture to microservices and going from, one release every 2 months to, thousands of releases a week, and all of the benefits that they've seen from an innovation standpoint. That's all very real. A lot of Lightstep customers, like Spotify and GitHub and so on and so forth, they deploy very, very frequently. Lightstep itself deploys dozens of times a day. There's a lot of benefit to this, but this parallelization of change, it has some problems. The idea is that you have independent management of these microservices, but this independence is an illusion. And that's the thing that makes this so hard and why observability has become such a hot topic, I think, is that if someone at the bottom of the stack pushes out a code change to some service here, and that code change doesn't go well, it will have ramifications for other services up the stack, which then turns into an operational change for someone else. And this operational change is a very, kind of unemotional way to say that they got woken up potentially in the middle of the night because their service went down, right? So these operational changes can be pretty catastrophic. And again, you have a situation where a code change to a resource has effects on other resources, which has effects on transactions, which has effects on end users in the business. So there's a lot of urgency around this. I think the anti-pattern, which you probably have suffered through at some point in your careers, is that you'll be brought into like some kind of conference bridge with hundreds of people who are all just trying to justify that it wasn't their fault so they can hang up. And you can figure out like who actually is responsible for this problem, and then maybe they can revert their change. But when you have thousands of changes going into a system every month, it can actually be pretty difficult to figure out what went wrong in some scenarios. And it's because these services are actually not independent. they're actually quite codependent as well. Okay, so we first talked about the relationship between engineers and end users. Even engineers and engineers have a lot of codependencies in a cloud native environment, which I think puts even higher, it puts an even greater burden on observability tooling to try to sift through all the telemetry to understand this. This is also when I'm going to mention distributed tracing. Distributed tracing is the only form of telemetry that actually encodes the relationships that between the services involved in a single transaction. So the whole point, if you're not familiar with it for tracing, is that you can follow transactions automatically from one service to the next to the next. And this diagram doesn't do it justice. A lot of microservice architectures have hundreds or thousands of services that are, layered 15 or 20 layers deep. And so being able to do that automatically isn't sort of nice to have. I think it's a total requirement to understand these sorts of systems in practice. And we'll talk about the kind of heritage of OpenTelemetry in a minute, but this is really important context for that. So let me see how we're doing. If people have questions, they should feel free to put them in the chat. I'm going to start talking more about observability architecture and OpenTelemetry in a second, but if any of this stuff wasn't clear or you have questions about it, drop it in the chat or use the Q&A feature, and I'll try to address that in real time. So, all right, onwards. So observability architecture and OpenTelemetry. So the conventional wisdom about observability looks something like this. Like if you're in a brownfield environment, which most people are, you have some kind of logging system and you have some kind of metric system. Metrics is going into a time series database. Logs are going into a log management system like Splunk or Elastic or something like that. And then you have some front ends that are integrated HTML level to provide some sort of solution here. And then you start moving into Kubernetes and microservices, and someone realizes that maybe there's a need for tracing as well. So you stand up another tracing solution alongside these things. These can even be all in one vendor, but the reality is that the experiences themselves are integrated kind of superficially. This is not right. This is like the wrong way to do it. There are various opinions about exactly what the right way to do it is, but if observability is kind of the swivel chair experience where you're moving from like a bunch of metrics dashboards and then over to an APM and then over to a logging system or something like that, it's very difficult to actually get to the bottom of the inter-service dependencies as well as the relationship between, again, the time series metric data and the transactional data from traces and legacy logs that can be imported into traces as well. This sort of picture does not work. The way that I think of it, I apologize. I'm trying to make this an editorial talk, not a Lightstep talk. I think there's some Lightstep branding on this next slide, but this is, if you can blur out the Lightstep piece of this you want, but this is how I very genuinely think things should work. You really should think of not 3 pillars of observability, but 3 layers of observability. And this could work for, however you decide to pursue this from a vendor standpoint or provider standpoint. The first layer is telemetry, which we'll talk about in a second. Without high quality data, none of this stuff works. And most people actually don't have high quality data right now. So that's a serious problem. And that's where OpenTelemetry comes in. The next layer is storage. I only mention it because the second you have your metrics data in one storage system and your event data, whether you call it tracing or logs, in another storage system, you've basically made it impossible to have an integrated observability experience from a workflow standpoint. If those 2 databases are separate and you can't do like effective and efficient joins between them, a lot of the things that I'll talk about later just aren't possible. And then from a workflow standpoint, monitoring is not being replaced by observability. Monitoring is an important part of an aspect of observability. Monitoring is when you need to like represent the health of some resource. There's that word again, resource in your system. And like, obviously, hopefully proactively get ahead of any issues with that health. And then the other aspect of observability is understanding changes to that health. The thing is, there's a lot of people who are doing monitoring well right now in the sense that they're able to understand health I think, pretty efficiently and effectively. The problem is that it's not actionable. Just knowing that a service has gone from being healthy to unhealthy is not sufficient for like diagnosing why that change occurred, and understanding those changes, whether they're reactive in an incident response setting or proactive as part of a CI/CD system, is a problem that almost every enterprise I've seen has not actually adequately addressed. And so the challenge is making the monitoring actionable and then making the more sophisticated aspects of observability accessible to kind of ordinary developers and SREs who don't want to become like super experts in observability tooling. So this is kind of the way I see the space in general. As I said a minute ago, very few organizations have a mature telemetry practice. I think those that have reasonable telemetry coming out of the systems are mostly doing that by paying a vendor for an agent. I think that it's a kind of a dangerous place to be because you end up very tightly coupled to that vendor. The idea with OpenTelemetry is to kind of blow that up and move it into the open source world. So let me talk about that. Oh, sorry, I'll get rid of that. Okay, so OpenTelemetry, why and what? Why does anyone care about OpenTelemetry? There are a few different parties that care about it, and it benefits many of them, which is, I think, why it's been such a successful project. There are three main pools of constituents. The first pool are end users and customers of OpenTelemetry. So what they get is portability, as OpenTelemetry is a vendor neutral project with support for basically like every major observability vendor at this point. Performance, in that it's always on and has negligible, if even not even measurable, effect on latency and throughput. And then all of the usual goodness of open source software, not just the lack of a vendor lock, but the security benefits of having open source and so on and so forth. So there's a lot to like about OpenTelemetry from a customer vantage point. For developers in the overall ecosystem, so by this I mean like the cloud providers, SaaS vendors that are providing some piece of infrastructure software that might be incorporated into an application. This OpenTelemetry is very appealing for them because they can emit data in a well-known format that will be compatible with the ecosystem of their customers, as well as the ecosystem of observability vendors. And this is why you see like AWS devoting dozens of engineers to OpenTelemetry, and similar sorts of investments from GCP and Azure. It makes life better for them because they don't have to spend as much time interoperating with a bunch of customer vendor combinations. And then finally, it's actually quite good for the vendors, observability vendors themselves. Despite what I was saying earlier about agents providing some lock-in, it's also a very inefficient model. Cloud native software is so heterogeneous with many different languages and then many different frameworks per language, that having a single vendor devoting adequate resources to manage their own agents ends up taking up 80+% of a vendor's R&D budget just to maintain those agents, and they're not even differentiated anymore. So there's a lot of vendor support for OpenTelemetry as well. Even if it cuts against some of their historical pitch, it ends up being a rising tide for everyone. And I think that's why the project is so successful. I don't think I have a slide about this right now, but OpenTelemetry has well over 3,000 committers at this point, and is second only to Kubernetes in terms of cloud native projects from a just commit velocity standpoint, and has like just a huge community of people contributing to it right now, as well as a lot of adoption in the end user community. I wanted to provide a little bit of a history, an early history of OpenTelemetry. Oh, sorry, I shouldn't dwell too much on Lightstep, but I started Lightstep in 2015. At the time, we started off with tracing as our first telemetry source, and quickly realized that people liked the idea of tracing, but they did not want to take like a hard dependency on a vendor. So I created Open Tracing along with Yuri Skuro, who was part of the Jaeger kind of the guy who created the Jaeger tracing open source tracing system. Which was then open sourced a year later. In 2018, Google released something called Open Census, which is quite similar to open tracing, but also included metrics telemetry. And then there's a lot of difficulty in the market because we now had two different open source projects that were both doing similar things. And so these two projects announced their merger basically in 2019. About 3 years ago, almost to the month, I think, we were at KubeCon in Europe, I think, actually, and announced the OpenTelemetry project. And then since then, there's just been an enormous amount of work. I think it was a year later, we released OTel in beta. And since then, it's gone GA for various components and then not GA for other components, which I'll talk about in a second. But the early history of the project, I think, is important to understand in that it started off really as an attempt to unify open source tracing, which was kind of greenfield. But now the project has also moved into metrics and soon into logging telemetry. And the goal for OpenTelemetry is to provide a decoupled surface that you can integrate against to get all of your cloud native telemetry out of your application and into your observability tooling, kind of regardless of what you want to use. So the architecture for OpenTelemetry is actually quite decoupled. There's the specification itself, which you can look in the OpenTelemetry GitHub repository. It's the specification repo. It's very formal. It reads kind of like it reads like an internet RFC or something like that, which is intentional. And there's a ton of, you can go and look at the threads. It's almost a little bit annoying how much debate there is, but a huge amount of debate going into specification, which is broken across tracing, metrics, logging, as well as semantic conventions for like how we should name this tag or that tag, really, really detailed stuff. The specification is then adopted by per language APIs. So OpenTelemetry has an API for every major programming language that's used for cloud native software. And then contributors are always adding new ones. I think we have everything from Java, .NET, and Go, and Node, those sorts of things, all the way to like Swift and Rust and Objective-C and things like that, right? So it really runs the gamut. And then you have SDKs, which are basically like a stock implementation of the API. So the API is a very thin dependency that basically takes a specification and makes it possible to bind to it in a given language. And then the SDKs are an implementation of those APIs that will give you an ability to actually export the data. So most end users who are adopting OpenTelemetry will want to integrate the SDKs into their software. For languages where it's feasible, like Java or Python or .NET, there are, much like you would for an agent in a commercial APM, you can adopt OTel SDKs post-compilation via just adding a dependency, and it will like hook in through a Java agent or similar. In other languages like C++ or Go, that's just technically not feasible, but there are very lightweight ways to bind the SDK, the OTel SDK for Go to the Go language runtime and so on and so forth. And I won't go into all the documentation because there's so much of it per language, but there are clear instructions for how to do that. Then there's all the instrumentation itself. So this is, in 10 years, when you talk about OpenTelemetry code, 98% of the code is going to be instrumentation. This is just like everything under the sun that should emit telemetry. We'll use OTel to do that. And that's a beautiful thing for all the parties I mentioned earlier, in that you get like pretty high quality telemetry without any sort of vendor dependencies. And some of the instrumentation is in the OTel project itself, but most of it will actually be outside of it. Like for instance, Kubernetes and Kafka and projects like that just naturally take a dependency on these APIs, and then they bind to that to emit their own telemetry. So it's not like you have to go to OTel to see the instrumentation. A lot of it's being built into software, just like you might take a dependency on any other logging or metrics API. And then finally, there's the collector. So the collector is kind of different than the rest of the stuff. The collector is actually like a real piece of software that you build and run on its own, as opposed to the rest of the stuff that kind of links into your existing application code or into someone else's application code. The collector is, it's probably deserves its own talk, but the short version is that You can run it either as like a sidecar agent or as a pooled resource that uses a ton of memory and CPU, but it's a way to ingest data in many different formats and then emit data in many other different formats. You can think of it as kind of a multiplexer for telemetry and of many different flavors of telemetry. So you can receive data in a Prometheus format and emit it in a LightSet format, or you could receive data in a Jaeger format and emit it in an X-ray format, that kind of thing. So it's actually very, very convenient and has been quite popular and has its own, it has its own development timeline, but is being used in production at scale by many organizations that I'm aware of. So I feel, pretty good recommending it. Now, the catch here is that the stuff, OTel itself, people often ask me, like, how mature is it? And it really depends on which aspect you're talking about. And that's kind of, I don't know what that's all about. I figured people would want to know, so, how mature is OTel? So I will tell you, but I'm not going to tell you by like presenting it on the slide. I actually want to show you how to figure that out yourself, because the story, I was writing the slides for this and I realized that, even this very week, there were changes to this. Like if you go to OpenTelemetry.io, the best way to figure this out is to go to status and just kind of go through it. If you're interested in using OTel for tracing, good news, like it's super stable. I don't just mean, none of it's going to like crash your stuff, but the question is, are you taking a dependency on an API that might change and require you to do work? The tracing API is stable and feature frozen at this point. This is very new. Like this API stability is just in the last couple of weeks, but the metrics API is also stable now, which is awesome. This was after, really more than a year of effort working with end users and the Prometheus community and others to get this to this point, as is the protocol. And you can see some notes here about where we're at. The SDKs are, even this morning, actually, the Golang SDK, I believe was GA'd for metrics. So this stuff is changing like day by day. And I'd say by the summer, metrics will be in the same place that tracing is, where it's just going to be through and through stable. I won't talk about baggage right now. It's kind of complicated and probably less relevant to you all. Logging is still really early. So if I wouldn't use OTel for logging unless you're ready for changes coming down the pipe. But most people are interested in using OTel for tracing and metrics first, but logging is underway. And we actually had a big announcement last week in that the Elastic crew have donated their own semantic specification for logs to OTel, so we can kind of collaborate on that. This is a great thing because I think a big issue with logging is just consistency in naming. And then again, the instrumentation is its own thing. If you want to understand the collector and its maturity, that's basically the same as protocol. So if you want to use tracing in the collector, that's stable. If you want to use metrics in the collector, that's also stable, et cetera, et cetera. So this is kind of the place to go on the OTel site to understand like the current status. And then when it comes to actually adopting this stuff, it does depend a bit on which aspect of the project you want to use. I think on the kind of mission and vision, we have a bunch of kind of design principles. This is one I would highlight. I'm on the governing committee for OpenTelemetry, and I'm always like kind of trying to hammer this point home that it's pretty loosely coupled. Like if you want to use OTel just for, the tracing API in Swift or something like that, that should be totally fine. And you should not be taking a dependency that brings in a ton of other stuff. So the getting started question does depend a bit on what you want to get started in. But generally speaking, if it's per language, you go to that language repo in OpenTelemetry. What's a good example? If you want to get started in Java or something like that, you can go to this repo and there's some getting started information. So that's usually the way that you would go about actually adopting this stuff in practice. I see that there's a question in the forum. Does OpenTelemetry require a background thread to execute? For instance, on Lambda or Cloud Run, the background thread will freeze after response, and would like to know if any extra handling is required to flush bands or metrics. That's a really good question. And for what it's worth, I have a rant about Lambda and Cloud Run and stuff that's related to this. The short answer is that you can, so the end game here is that those sorts of services like Lambda, for instance, will likely be emitting OTLP, which is the OpenTelemetry protocol, will be emitting OTLP kind of natively. That's one of the beauties of the cloud providers getting in on the OpenTelemetry piece. It would be required, though, to either have a background thread running or to flush at the end of the, hopefully after you've actually sent the response back, but to flush on a per request basis. Like somehow, yes, that data does need to get over the wire. It really pains me to do that flush on a per request basis, just for, I think, the same reason you probably don't want to do it. It's just like a lot of work and you don't get any of the benefits of batching. So a background thread would be, I think, an ideal thing if possible, as a kind of contingency plan until the cloud providers support the stuff natively. But as I said, the end game is that the cloud providers really should, and I think will, provide support for OTLP natively in those sorts of serverless function products. I hope that made sense. All right, so I think I've got another 10 minutes. Let me go back to my slides for a second. So I've talked a bit about teaching you how to fish on OpenTelemetry status. Again, I think that's more important because if there's one thing to understand about OTel right now, it's that it's moving very, very quickly, and there are a ton of people involved in the project. So whatever the status is today will change next month, and that's probably going to be true for the next year or so, just given the amount of development happening. I did want to, if I go back to, like this slide or this slide, I'm talking about the idea that like the telemetry is just the bottom of the stack, and that there needs to be some kind of integration that happens above. I do think it's probably a good idea for me to try to make it more concrete for you all to understand what I mean by that. So I am going to show like a quick demo. I'm going to use Lightstep because A, I'm familiar with it, and B, I frankly just don't know of anywhere else you can see this right now. But it's not meant to be so much like a product pitch, is just trying to illustrate what I mean by tying together metrics and resources with transactions. Like any live demo, there's always the opportunity for things to go wrong. So hopefully that won't happen, but let me show you what I mean. So I was thinking about this and I decided not to use like fake data. I'm actually going to go to Lightstep's own meta monitoring. So here you have a dashboard that we have internally to monitor Lightstep. This is, pair this host name. This is like a separate, totally segregated instance of Lightstep that we use for self-hosted monitoring. This is what I'm hoping is a very familiar looking sort of dashboard that's all about resources, right? So we have a service called Trace Assembler, which, as you might imagine, assembles traces. It does a lot of work. Like we have customers that have 1 billion transactions per second. So there's a lot of stuff that flows through the system, and it's very important that it remains healthy, right? So we have some dashboards set up to monitor that health. And one of the things you need to check on is CPU usage. Obviously, if these numbers creep up past 90%, you're going to be in for some kind of nasty surprises, right? So we're always trying to keep tabs on this. And I'm sure that you all have seen things like this before, where there's some kind of anomaly in this area. Those sorts of anomalies, you can try to group by host or something like that, which is what we're doing in this chart. That's honestly not that helpful. Like it's what happens almost always when you have CPU spiking, it's because the transactions changed in some way. And the question is how. This is what I'm talking about when I'm saying you cannot just like have a separate tab. Like going over to look at logs for this is not going to be useful, nor would actually just manually looking at traces. You need something that can actually integrate at the data layer and say, I want to join these metrics for these hosts over to the workload for those hosts and understand what changed in the workload. And so with Lightstep, we've spent quite a bit of effort like making this possible, where you can click on something like this and then say what caused this change and bring up a UI that's specifically designed to explain that. So we start with the change in blue and the baseline in purple. If we want to, again, we can expand this and see in more detail like what's actually happening. As I mentioned earlier, looking at this by host doesn't really explain the issue because it's not a resource level change. And this is just earlier today. This is like a commonplace sort of thing. What we want to do is like understand what the what changed in our actual workload. So what Lightstep is doing here is it's looking at the various things that this service actually does. This is all like automatic. I think that I would suspect that it's going to actually find an issue with this get trace call. I think I actually have it over here too. Yeah, so if I look at get trace, what you end up seeing is that we take 3,000 traces from the baseline, 3,000 traces from the deviation, and compare the statistics between those two. And it turns out that one of our customers, the reason I want to come over here to this window is because I want to make sure I don't show anything confidential. It's on our website that FactSet is a customer, so I'm allowed to say this. So FactSet increased their load from 5% of our traces to over 25% of our traces in this one call during that window. And that's going to be the explanation. If I want to, I can go through and understand, well, what was the dependency diagram for where FactSet was making the request to where we saw an increase in load. And if I want to, I can go on to look at example traces for what was FactSet actually doing. And here's the distributed trace showing me that exact information along with, a whole bunch of other, context about what they were doing. So this sort of analysis is basically impossible if you have siloed metrics and tracing or logging systems, but I think is actually very, very powerful for understanding how resources and transactions and services interact in a cloud native system. But it's only possible if you have high quality telemetry from something like OpenTelemetry and like a unified database and workflow layers on top of it. So I hope that's sort of useful. I'll stop sharing. I think we only have a few minutes, but hopefully I'm free until the end of the hour. I'm happy to take questions at this point. So any questions? Sorry for all the words.
Thank you so much, Ben. That was really great. It's great to see the number of participants actually not only stayed stable but increased. We're at the peak right now, so that's a really good sign. Usually, you got a question from Francis. If you want to take it.
Yeah. So I see. Can OpenTelemetry span across async messages? Service A talks to Service B via Kafka, and if so, how is that shown on the message via header? That's a really good question. So. Literally, yes. And I think Kafka, the core developers have done some really nice work at Confluent to make header propagation work as like a sort of a place to stick context propagation alongside the user data in Kafka. So it is possible to do that. With open tracing, when we were designing that early on, we created two different types of parentage relationships. You could either have like nested RPCs, like that trace I showed a minute ago, or you could have what we called follows from, where one thing causes another, like in Kafka. So from a data modeling standpoint, yes, the answer is yes. There are two problems with it. One is that Kafka has a lot of coalescing effects where it'll have like many messages will get batched together and then sent and have a shared fate. And that can be difficult to represent in an observability system that does a lot of sampling. Some systems like Lightstep don't do that much sampling or do no sampling, which makes it a bit easier. But if you're doing like a Zipkin or Jaeger type of thing where you have aggressive sampling, that can be really hard to successfully. It can be hard to use those sorts of tracing systems successfully with a batch mode system like Kafka. The other issues in the UI, those sorts of trace visualizations I just showed are really designed for nested RPCs and critical path analysis on those. In a Kafka environment, you can see it, but honestly, I don't think that the tracing UIs are very well suited to understanding message queuing systems like Kafka. You can still get a lot of value out of the tools by doing programmatic work, but Kafka, similar tools do require some special analysis. I put something on Twitter about a year ago showing how we analyze Kafka with Lightstep. If I remember, I'll throw that in my materials to distribute after the webinar. It should give you a little bit more detail. Okay, there's a question around just the recording. Yeah, this is being recorded and we'll send that out.
Yeah, we'll send it out later, tomorrow morning.
Any other questions? I'm curious if people thought this made any sense. I was sort of hesitating, like I initially just had a big talk on like OpenTelemetry, just standalone, and then I felt like it would be more useful to step back. But if people found this to be totally confusing or overwhelming, I'm open to the feedback because I'm doing lots of talks like this, and I like to hear what people think of it. So it made sense. Success. Before the presentation actually started, I got a question from Luca's co-host about whether these plants were real. They are real. They're real plants. There are my wife during COVID just got like really like ambitious about plants, and then she sticks all the ones that are too big for other places into this office. So it's kind of like a botanical garden in here. Okay, here's a real question. Under what circumstances am I looking at OTel versus Prometheus? The answer is yes. You're doing both potentially. Prometheus is a complicated project, just like OTel, where there's Prometheus protocols, both for getting data as well as querying data. Then there's Prometheus infrastructure, and then there are things like Cortex and Thanos that are kind of Prometheus compatible, but actually somewhat like competitive with it in the sense of providing long-term storage. So OTel and Prometheus communities have worked quite closely together. The wire protocols for OTLP are meant to be Prometheus compatible, and it's possible, in fact, to run Prometheus software and then use the OTel collector to ingest that data. So there's no great conflict between using Prometheus and using OTel, and that's intentional. There's like a better together there. I would say Prometheus as a piece of software to run at scale for doing actual metric storage and querying is not a good idea. But has nothing to do with OTel. I think there are other solutions, even in the open source world, that make more sense for that. But I will say that, but that's not really, I think, the essence of your question. It just doesn't, it's hard when you need more than one machine to run Prometheus. You should probably look into some of these other tools, whether they're open source or commercial. Which cloud vendor is furthest along with native OTel support? I mean, I have to say Lightstep because I think it's true, and I'm wearing this shirt, whatever. But we did a lot of work with OTel early on, and so it's always been our kind of first priority to support OTel, and we support it both for tracing and for metrics. And there aren't many, if any, vendors out there that really do that in earnest well for both those signal types. Can I elaborate on the tracing metrics correlation? OTel has a role in potentially collecting data, although Lightstep can collect data from other sources as well. Like we can ingest data directly from Prometheus or from Datadog for that matter. And then the correlation you're seeing, when I had that diagram, it was like OTel, storage, workflow. The storage layer is really the piece there. I haven't been talking as much about my background, but the core team at Lightstep designed Google's kind of planet scale tracing and metric systems. So at Lightstep, we designed like one database that can represent both types of data, and that database can perform the join that made that analysis possible. So that's a Lightstep feature and not something that OTel can give you, although at least OTel can provide the raw data to make that analysis possible. Suggestions for larger than prom scale open source metrics aggregators. I think, yeah, I mean, I think Thanos and Cortex are an improvement in the open source space. I think for commercial stuff, obviously I'm biased, but Lightstep's metrics solution is quite scalable. But there are a number of other commercial metrics vendors if you're looking for that as a standalone thing. I just think that they're pretty siloed, whereas Lightstep's approach is more integrated. Jaeger, I'm seeing Perry's question. We've had Jaeger stood up for more than a year, but not much interest from app teams to instrument for it. How do I get buy-in? This goes back to my concern about observability use cases being expert only. Jaeger is a good tool, and I think Yuri's really smart who designed it. But it's a standalone tracing solution. The solution to make tracing more useful is to build it into monitoring. So the second you can access tracing through monitoring workflows is the second it becomes useful. While it's a segregated tool, it's never going to be the first port of call for incident response or just ordinary monitoring use cases, and that makes it hard to use. The most successful tracing deployments build tracing into those kind of core workflows, and then it's not something you need to remember to go to, it's just there. And I think with a siloed tracing approach, that can be difficult to achieve. Would this support Lambda at Edge? That's sort of up to Amazon, but no reason it wouldn't. And Amazon seems quite committed to OTel, and they've been great partners, so I'd expect that will happen. I just don't know when, because I don't work there. Any other questions? Those are fantastic questions, for what it's worth. Any other questions? Would Loki be useful for linking logs? So, I mean, I think this is, so building tracing into core workflows with metrics and logging. Would Loki be useful in this scenario for linking logs? I mean, I don't know. I mean, I don't work on it, so I don't want to speak too much about what Loki is capable of and not capable of. But I will say that most of these integrations are happening like very, very high up in the stack. Again, kind of at the HTML level. For the integration with logging to really be fluid in the way that I'm trying to see observability evolve, it has to be integrated at the data layer. And I think, I might be wrong, but I think Loki's data layer is a separate thing. And that's going to make that really hard, because the joins that are needed at the data layer won't be possible if that's the case. I think it would be more likely that you'd end up seeing a spike in, maybe you'll see a spike and it's correlated with some host name, and then you could look up logs for that host name, but that puts a lot of burden on the operator, and it's going to be a very noisy investigation. So I'm not that optimistic about that approach, if I'm being honest. I think I'll take a couple more, since these are good questions. Building tracing into core workflows with metrics and logging. Okay, do we have a roadmap for OTel with regards to logging component? I'm hesitant to answer that. I think literally yes, but I'm not super confident about the delivery, because I'm not. The trouble with open source software that's a true collaboration is that you have many different parties that are trying to collaborate. I think it would be a very good question to ask at the logging SIG. If you wanted to go, you could even just file an issue if you don't feel like showing up. But there's like a public meeting for the logging SIG in OTel where you could ask for, how serious is this roadmap or something like that. I would say that logging of the 3 signals was done last, partly because it's going to be the most complicated. The logging ecosystem is just so complex. So I wouldn't be surprised if OTel had stable logging APIs pretty soon. But the real question in my mind, like for metrics, we had to integrate with Prometheus to make that work. But with logging, it's like there's so much stuff that you want you to actually deliver a solution on OTel, you're going to want to integrate with a lot of other stuff. Everything from the now shamed Log4j project to like all sorts of totally legacy brownfield logging emitters that need to somehow get brought into the fold. And I just don't know the roadmap for all that stuff off the top of my head. And I think it's a good question, but for delivering the logging solution for OTel, a lot of those pieces have to be put into place, and they're just not ready yet. So I don't know the timeline on that stuff. I think I would say metrics and tracing are going to arrive in a sort of solution way, are going to arrive quite a bit earlier than logging. But I think it's eventually going to happen. All right, last question, and then I'm going to stop. Is there a case against OpenTelemetry? Looking back, anything that should have been done differently? Yeah, definitely on the second part. I'll just be honest about that. So I don't think there's much of a case against the idea of OTel, which is why it's been so successful. I think it's, there's a question of whether it could achieve escape velocity as a project, but once it got to that point, it really does benefit everyone in the community. And that's why it's not difficult for it to make progress. The thing we should have done differently, I did not expect it to be as successful as it's been. And that is creating problems. I think the fact that we have, if it's one of these things where if we had 1/10 as many committers, we'd probably be further along right now. But there's been so many donations of like really valuable technology. There's a bunch of stuff with eBPF recently. There's another eBPF thing before that. Stanza donated logging stuff. And then there's all this, every time that happens, it kind of like distracts the governance committee into figuring out where to put this stuff. When I think the main thing we probably should have been focused on is just saying, thank you so much. Can we wait until we've released a stable tracing and metrics solution? We are finally there, but I think we would have gotten there earlier if we had been more focused on just delivering those solutions earlier on. The good news is that now we finally are doing that, like literally now, for metrics and last year for tracing. So all is well that ends well. But I think the project at times has been a victim of its own success. Just with the sheer amount of activity, it's been difficult to govern. And unlike a Kafka or something like that, this is not an open core project that has committers from one company. There are committers from dozens and dozens of different companies, many of which are competitive. So it's good in the sense that I think it's a good check and balance on the project, but it makes it harder to just coordinate on execution like you would for open core companies. A net positive in the long run, but it does provide for like a little bit of extra friction in the short term. All right, those are some of the best questions I've ever seen in a talk I've done about anything really. So thanks everyone. Hope this was useful. Luca, anything you want to say as we close out? Or
no, I think this was great. Super engaged audience. So thank you everyone for joining, for the questions, and thank you, Ben, for the time. This is really great.
Cool. You got
We'll send over the recording. No worries, everyone.
Yeah, and please reach out to me on Twitter or whatever if you want to chat. I always like hearing from people. So thanks.
Also, we can share your handle in the follow-up email as well, Ben.
Okay. Okay.
All right. Bye, guys. Bye, everyone.